In this video, we are going to explore the percentage yield of a chemical reaction. So before we get into that, we first need to define what the experimental versus the theoretical yield is for a chemical reaction. So sometimes when conducting experiments, the values that we get don't always match up with what should have happened. And so that leads to two terms that we're going to be using to determine a percent yield. The first is the experimental yield. So this is what you actually got by completing the experiment. This is something that's measured. So if you did an experiment and then measured a mass, that would be your experimental yield. The theoretical yield is what the balanced chemical equation and calculations tell you should have been produced. This would be calculated using stoichiometry. The percentage yield of a chemical reaction is going to compare the experimental yield with the theoretical yield by taking the experimental yield, dividing it by the theoretical yield, and multiplying it by 100%. Let's look at an example then. If we take sugar and break down sugar into C2H5OH, which is ethanol, and carbon dioxide, the first part of this example asks us what the theoretical yield is of ethanol from 10.0 grams of sugar. So it's important to recognize theoretical yield means you got to do stoich. So remember our steps from stoich. We want to make sure we have got a balanced chemical equation, which we do, so we don't need to balance that. Our second step is we're going to take our known value, our 10.0 grams of sugar, and convert that to the number of moles. So the moles of sugar is going to be the mass divided by the molar mass. And we got 10.0 grams. And if you find the molar mass of the sugar, you should get 180.18 grams per mole. And that is going to give us 0.05550, so on, moles of sugar. Now we want to set up a mole ratio between the sugar and the ethanol. So we know 1 mole of sugar gives us 2 moles of ethanol, and that's from our balanced chemical equation. And we've calculated we've got 0.05550 moles of sugar, and we're trying to find the moles of ethanol. So solving for x is going to give us 2 times the moles of sugar, which is 0.1110, so on, moles of ethanol. Finally, whenever they ask for theoretical yield, what they're asking for is the mass produced. So we need to find the mass of our ethanol. And so we're going to do moles. That should be moles times our molar mass. And we're going to take our 0.1110, multiply it by the molar mass of ethanol, which you should get 46.08 if you calculate that. And that would give us a mass of 5.11 grams. Okay, and that's the mass of ethanol that we would expect to be produced. In an experiment then, and this is part B of our example, it's found that 10 grams of sugar produced only 0.664 grams of ethanol. What is the percent yield? So this 0.664 is telling us that this is what we got from our experiment. So it is our experimental yield. So to set up a percentage yield, you're going to take your experimental yield, which is 0.664 grams, and divide it by your theoretical yield, which we just calculated was 5.11 grams, and then multiply that by 100%. So you get 13.0%. That means that only 13% of what we expected to be produced was actually produced in this experiment. A really low yield means that our experiment wasn't, or our reaction is not very efficient. It's not producing as much as we would think. Whereas if you had a high experimental yield, you'd be producing a lot of what you would expect.